Network Dojo.
All right, so now we see our AP attempting to join the controller that we want it to join, but you know what? It still can't join that controller. So now we're troubleshooting the join process here. So first, make sure that you are seeing your AP attempt to join the controller in question. So we saw that DTLS log that specified the IP address it was trying to form the DTLS connection to. That lets us know, okay, yes, it's trying to join the controller that we want. Pay attention to, is it trying to join over IPv4 or is it trying to join over IPv6? Not that it's wrong one way or the other necessarily, it's just that we want that for our information. So if it's saying that it's trying to join 10.0.4.11, it's trying to join over IPv4. If it says it's trying to join to an IPv6 address, obviously IPv6. So if it's using a method that you don't want it to use, maybe we fix that. Although again, the first time, at the beginning of the lab, APs are at a blank slate, and they should just be using IPv4 as their default method to begin with. So usually on the initial join process, troubleshooting, everything's always going to use IPv4 for the most part, unless the controller, for whatever reason, is not even advertising an IPv4 AP Manager interface, which would be a little weird if that was actually the case. We can look at the AP join stats for clues, because when a join attempt fails, there are logs generated in the controller, and the AP join stats will have errors in them. And sometimes the errors are extremely helpful, sometimes they're very vague. But sometimes they pretty much say, oh yeah, very clearly, this is the problem right here. And you can just immediately go ahead and fix it. And then the other place that I usually go is I look at the AP logs for clues, because the logs, while not as helpful for the join process, they can still sometimes have some helpful errors. Like expired certificate errors are oftentimes very, very obvious in the AP logs. Unfortunately, a lot of the other problems aren't. So AP join stats usually have a little bit better clues, but again, we're just sort of, sometimes one place has the better clues, sometimes the other, and it all depends on the reason why we're not joining. So we want to sort of know all of our options to try to gather as much information as possible. So again, look at those AP logs. We want to see, once we're forming the DTLS connection, and then did the DTLS connection get up? And then we should see that the join attempts are requested, and then the join attempt should succeed. The AP then gets configured, but obviously something is going wrong in here. So look at the logs, and is there anything helpful in the logs that get put, or is it just pretty generic type stuff? In the AP join stats, again, if something goes wrong, number one, make sure that we sent a response. If we didn't send a response, it's not going to try to join. So usually then we go to join phase, and if something went wrong, there's going to be this reason for last unsuccessful attempt, and this could have some helpful information, or maybe it has some very vague information. But maybe it's, this is another place to look for information here. So if that doesn't sort of reveal the issue to you at this point, the other thing that you can do is use I call it my cheat sheet method. So with this, in the lab, there's really only so many reasons why we won't be able to join. And it's fewer reasons than what we have in real life, because it's a controlled environment. We have a known model of AP, we have a known model of controller, we have a known code level. And so based off of that, there are some things that just cannot happen or cannot go wrong in our lab here. So here are the things that are pretty much, if something goes wrong, it's one of these things. Because anything that goes wrong, we have to be able to remedy, right? So it's not like they're going to say, give us an old, ridiculously old AP that can't join up to this code and there's nothing we can do about it. That would be silly. So if you run through this list, you should find the problem here. And so in no real particular order here, here's the list of things that can go wrong that we would have to fix to cause our APs to join. So connectivity between the AP and the controller's AP Manager interface. So we discovered the management interface, but we joined to an AP Manager IP address. The thing is, in the lab on a 5508, it is pretty much 99% of the time the management interface is our AP Manager It's very rare that they would either have pre-configured separate standalone AP managers or ask you to configure separate standalone AP managers. So usually it's one and the same, but always worth a check. Now the trick here is that it's really hard to validate layer 3 communications between AP and controller for specifically UDP 5246. We can ping it. We could maybe try some TCP testing if the APs allow for like a telnet style command. But at the end of the day, there's really no good way to test UDP 5246. Now, if discovery worked, generally that's a pretty good sign that layer 3 communications is there, but not always. So what I would say is if everything else checks out, go back and really focus in on layer 3 and see what's going on. Is routing good? Are there any ACLs blocking the CAP/WAP traffic or something to that effect? Try to figure out what might be from a layer 3 perspective going on, because the rest of these are very straightforward. Either it's a yes or a no, and there's really no way to hide it or be sneaky with these other things. There's easy ways to be sneaky with layer 3. Okay, next up, bad controller date. If the controller's date is so wrong that it thinks that the AP's certificate is either not yet valid or is already expired, it will reject the AP's certificate. So as a part of the join process, the AP sends its certificate up to the controller. The controller needs to validate that certificate. If it's out of the validity period, it will reject it. So check the date on the controller. If it's a decade or two into the future, that's a problem. If it's somehow a decade into the past or whatever, or significantly into the past, that can be a problem too. Next up, AP policies. So AP policies to say what type of certificates do we accept. MIC APs, SSC APs, and LSC APs. We just do MIC. So if MIC APs were turned off, we would reject it. We also see here where we would enable AP authorization. So if they turn on authorization, usually we don't have the proper MAC addresses populated somewhere, and it will fail the authorization phase. Regulatory domain issues. All of our APs in the lab, regardless of where in the world you take this lab, will be -A, -B regulatory domain APs, US-based APs. And US is the default country code on our controller. So usually it's not a problem, but if they change that country code to something besides US, something in Europe or maybe in Asia or anywhere in the world that's not -A, -B, it will prevent our APs from being able to join up to the controllers. No AP manager. And here you wouldn't even see the AP trying to join the controller. If you don't have an AP manager, we don't send discovery responses back. But if they turn off AP management functionality from the management interface and don't configure a separate standalone AP manager, we're not going to be able to join at that point. On top of the AP manager, if they have an AP manager, which they probably will, but they enable NAT on the AP manager, that will change the IP address of the AP manager that they advertise, maybe to some bogus IP address. And so your AP tries to join to some weird IP address. So if you ever see that, why is my AP trying to join to some random IP address? It might be because they configured NAT on the AP manager interface. And then finally, if your AP is in mesh mode or bridge mode, there is the extra limitation that every mesh AP will always have to pass a MAC auth every time it joins up to the controller, even if MAC authentications aren't turned on globally. And so if they have flipped your AP into mesh mode or bridge mode, you need to make sure that the MAC entry is populated. And if the AP shouldn't be in mesh mode, I guess then you would just want to put it back into local mode at that point. We used to have an extra limitation on mesh mode APs where it would only join a controller that has one country code configured. And so if we had multiple country codes configured, even if we were in the right regulatory domain, it wouldn't join, but that restriction has gone away in the code level that we're currently at right now. So again, it's all, any one of these things can cause things to join, but this is basically the list right here. And again, everything except for the first one is very cut and dry, very easy to verify. And so if everything else looks good, spend some extra time on that layer 3 and try to see what might be going on there. But let's show you how I would work my way through validating these things. So I'll start with everything but layer 3 and end up on layer 3. So for me, I work my way right to left. I don't know why, but that's just the way I do it. But just have a pattern so that you hit the same things every single time. Okay. Commands, time. Is it this year? That's probably fine. Is it today? That's perfectly fine. We don't need to worry about hours and seconds or anything like that. But is it today, this month, this year? You're probably okay, at least in terms of AP joins. If not, either manually set the date or we can use NTP. I would say look at the guidelines and see that if they give you any recommendations that if you need to fix something time related, if you have to use NTP or if you're allowed to do manual time configurations, just pay attention to that. Then we have our AP policies. This is what we want to see. We want to see that mix are accepted and that we are not authorizing APs. If this is turned off, we turn it back on. If this is turned on, turn it off. We can always configure this. If we need to configure AP authorization, we can always configure it later. But let's just get things joining first. Regulatory domain, that's controlled by our country codes. Is it anything besides just US? If so, it shouldn't be, unless they explicitly tell you this is the country code we need. But remember, all of our APs are -A-B, which is what we get when we choose US. So there's not a ton of other options that give us, other country code options that give us this regulatory domain. So if it's not US, make it US. You do have to turn radios off in order to change this though. All right, look at our interfaces. Do we have an AP manager? Something should say enabled under dynamic AP management, and it's pretty much always the management interface. If there is nothing that says enabled, again, usually we use the management interface, go to the management interface, check the box for dynamic AP management. And while you're in here, this is also where we would validate NAT. So whatever your AP manager is, pop into its interface, look to see is NAT turned on, if it was turned on and, 99, 99, 99. If it's like this, what you would see is your AP is trying to form a DTLS tunnel to 99.99.99.99. Obviously, that's not going to work in my IP addressing scheme here. So make sure that NAT is turned off. And that's all of them, except for layer 3 connectivity as well as the mesh AP restriction. But for that, we're going to go to the AP. So the controller is obviously online because we're in the GUI. So at a basic level, the controller itself is connected to the network. So usually if there's a layer 3 communication problem, it's probably more closer to the AP side of things. But again, let's pretend that LEP1 was having the problem. If you want to check the mode, there's a number of commands that show the mode, but show capwap client config is one of them. So on that second page, the AP mode, it should say local. If it says bridge, you can flip it back to mesh or local with test mesh mode local. You're supposed to. Did I miss something here? Test. I wonder if it's because I'm already joined. So if test mesh mode local isn't available to you, you could also try to do a clear capwap private config, save and reboot. Although every once in a while I have to do it twice to get out of mesh mode for some reason, and I don't know why. So a couple of options for you there. But yeah, get it back to local mode, or worst case, just add the MAC address for the AP so that it can join up to the controller, and then through the GUI, you could flip it back into local mode. So either way will allow the AP to get joined up to the controller. But let's say that we want to try to figure out layer 3. So start off with a ping. Can I ping the controller? Now, if the answer is no, obviously we have a problem that we need to solve, and we look at routing, we look at DHCP configurations of the AP, all that type of stuff. But if pings work, that doesn't necessarily mean that we have proper layer 3 connectivity, because there is a feature called proxy ARP that can allow a ping to work when it really shouldn't. So if a ping works, another command to just tag onto the end, show IP route, and look to see, have we learned a default gateway, which we should have learned through DHCP, and is it correct? Did we learn a default gateway? Is it correct? If the answer is no, go fix your DHCP pool, add the default gateway, or fix the default gateway. Unfortunately, if you omit teaching a default gateway, pings will still work because of this proxy ARP feature, which is on every SVI that we have by default. So unless they actually turn off proxy ARP, which don't expect them to do that, then the pings would stop working due to the lack of a default gateway. But so why does proxy ARP work for pings and not for CAPWAP traffic? I honestly don't know. But I do know that that's why pings work when they shouldn't. So again, just because a ping works doesn't mean that you're still out of the woods. Check for that default gateway. And usually at that point you're okay. Now if pings work and your default gateway is good, boy, we're really starting to scratch our heads here. I would be looking for potentially ACLs on either the wired network or maybe a CPU ACL on the controller that's specifically blocking, CAPWAP 5246 traffic. But the thing is, since our management interface is usually our AP manager interface, we usually, if it's like an ACL, that would break the discovery and we wouldn't even get to the join on that. Whereas, I don't know why, I've seen where sometimes the discovery works, but the join doesn't work when we don't have a default gateway. So that one's just a sneaky one. And it doesn't happen too often, but I've had students run into that where they just forgot to add it to a DHCP pool. And it's happened enough now that I know to look for it just because I've suffered the pain of not realizing it right away. But that's just some things to be looking at. So again, layer 3 can be a little sneaky, but the other ones are very cut and dry, whether it's configured correctly or not. And so at that point, we should be able to get through the join. So memorize this, practice it a handful of times, and you should be able to zip through this and use this method to honestly find the issue. As long as it's not a sneaky layer 3 issue, you can usually find that in like a minute by just zipping through these pieces of config. Last thing we'll talk about is joining across a NAT. So we don't see this honestly too much anymore. We used to see it a lot more back in version 2, but that was a slightly different design of the lab that sort of pushed us into this design. But the way that the lab is designed from a topology standpoint now, NAT is a much less likely solution. It may or may not be possible, honestly. It just depends on, there's only one device that might be able to even do NAT for us. So, but if it is, usually here's the design. If we're joining across a NAT, we're usually pretending that we have an AP living out on the internet somewhere, someone's home office, that's trying to join up across the internet into like a DMZ, probably. That's usually the scenario where NAT's going to come into play. Otherwise, why would we NAT in an internal network? So, usually what we do is on the AP, we configure our controllers as primary, secondary, tertiary controllers. But when we configure the primary, secondary, tertiary, we need to make sure that we specify the public IP address of the controller, the pre-NAT IP address of the controller, so that it can talk to that. The device will NAT it to the real IP address of our controller here. And then we need to make sure that we enable NAT on the controller, calling out the appropriate public IP address. And then the only other question after that is, does the controller also need to support internal APs? So I'll just show you the controller on the config side of things, because I think you can hopefully figure out how to configure a primary controller on an AP at this point. So let's pretend that my public IP address was 9.9.9.9. And that public NAT translates to 10.0.4.11. So I go to this controller, I enable NAT, I say 9.9.9.9. So what this does is that in my discovery responses, I say, okay, your AP manager IP address is 9.9.9.9. That means that the AP will attempt to join 9.9.9.9, which will then translate to here. Everything should be happy. The only trick is that once I turn this on, every discovery response only includes this IP address. And so this usually breaks internal APs from being able to join to this controller as well. And so if there's the additional requirement that APs on my internal network must be able to discover and join this controller, at that point I need one extra command. It's a CLI command, config, network, AP discovery, NAT IP only, disable. And then it advertises both the NAT and non-NAT IP addresses in the discovery response, and that supports external APs, it supports internal APs. Everyone should be able to ultimately join up, barring some other issue somewhere that we've already learned how to troubleshoot those. So in the event of NAT and NAT APs not joining, this is basically setting us up to make sure that we can properly discover and attempt to join the controller. And so we should see the AP trying to join, in this case to 9.9.9.9. If we see it attempting to join to another IP address, there was a misconfig in your NAT config on the interface. But once we see it attempting to join the proper IP address, and if that's failing, then we're back to that cheat sheet list. We're looking at the AP join stats because there's some other problem that we need to resolve. So, a lot of information for sure. Practice, lots of practice. Workbook 2 is going to give you lots of practice. Workbook 3 are going to have lots of practice scenarios surrounding this as well. And so the more time you can put into experiencing issues going wrong and just committing a few of these important things to memory, I think you'll be pretty well equipped in the lab that you can just run into spot the issue, fix it, move on without wasting a lot of time.